All right, welcome. In this video, we're going to talk about pointers to structs. So let's refresh some things we know about structs. So we have our new data type we've created called student. So let's, up here, we're going to recreate our new data type called student. You use typedef struct. You fill the fields, char, L name. The last name is an array size 20. There's an integer for the ID and a double for the GPA. And the name of our new data type is student. And we're going to be implementing two functions. The first function is going to be a function whose return type is a student. And it's going to be called fill. And this is a prototype, and basically what it's going to do is it's going to declare a temporary student, fill that temporary student, and return it. The second function we're going to do is a function that's going to have a void return type. It's going to be called fill pointer, and instead of filling by making a temporary student, it's going to actually go into memory where the student is and fill the fields of the student by reference. So the argument that it's going to take is a student pointer. So these are the prototypes. Now you can call these functions from within any function in your program, but I'm going to declare the instances of student in my main function. And we will fill them, we will declare 5 students. So we have student S1, S2, S3, S4, and S5. So we will fill a few students by student pointer, and we will fill a few students with the other way. So you don't even need to have the function definitions completed in order to make the function calls, because all you need to do to make a function call is you need to know what argument you need to pass to it and what it's going to return. So if I wanted to fill S1 by calling the fill function, I would just say S1 equals fill. I could call S2 equals fill. And these functions would be called, which I'm going to put the implementation on the right in a second. Now, if I wanted to call the fill pointer function, the fill pointer function does not have, it has a void return type. So I would make the function call to fill pointer, and I would pass it and add the address of, say, S3. Or I could pass it the address, or I could make another call to fill pointer, and I could pass it the address of S4. So this works just the same way that pointers worked. As long as I declare an instance of a student, all I need to do is put the ampersand in front of it, and it becomes a student pointer. All right, so now let's implement the functions. Let's do the fill function first that has the student return type. We've already done this in a previous slide. So very quickly, the return type is student. The name of the function is fill. What this is going to do is declare a temporary student. And it will prompt and fill the fields one at a time. So scanf into temp dot L name and scanf. Of course, you would want to prompt. You want to prompt before each scanf. I'm just out of space. Into %d into address of temp dot ID and scanf. Of course, you want to prompt %lf into address of temp.gpa, and then return your temporary student that was created. So in this instance, that would be calling this function right here, fill. It would jump over here, declare a temporary, enter the last name, scan into the last name, enter the ID, scan in the ID, enter the GPA, scan in the ID, have that all filled, take that result and assign it to S1. Then with S2, you do the same thing. You jump here, declare a temporary, fill it, fill that result, and assign it to S2. Now we're going to implement the fill pointer function. The fill pointer function has a void return type, and it's called fill PTR, and it takes as its argument a student pointer. So it takes a pointer to a student as its argument. So I do not need to declare a temporary student because it's going to go directly in memory and it's going to fill the fields directly. So how does that work? Well, you would have to prompt, of course, but I don't have space. So with scanf, if I want to go into the %C for the last name, the name of my student pointer is going to be SPTR dot LName. Now the thing that you have to realize here is that SPTR is not a student. SPTR is a pointer to a student. So in order to get there, I need to go to the value at SPTR dot LName. So it's kind of confusing because I'm dereferencing the pointer to my student right here, which SPTR is not a student. SPTR is the address where a student is located. So you're going to have to go to the value at SPTR dot field name. Now because the field name is a character array and it does not require an ampersand, you do not need to use an ampersand. But if I'm scanning into the ID, I'm going to go to %D. I'm going to go dereference my pointer, SPTR dot ID, and because ID is an integer, I'm going to have to put the ampersand. I better write that neater so you can see it. %D. I do need to put the ampersand there because ID is an integer. So this is one way to get to the fields with a pointer to a student or to your new data type. The other way would be scanf %LF, and yes, you need the ampersand, but instead of putting the dot operator and going to the value at, you can go SPTR with a little arrow, which is a dash and a less than, to the field, GPA. So when you're dealing with pointers to structs, you have two options. So if my pointer to my struct is called SPTR, I can either go to value at SPTR, and the parentheses are required, or you can just go SPTR with like an arrow that points to the field. And what do you put after the dot or the arrow? You put the field name. So you could put LName. In this case, I have these field choices: LName, ID, or GPA. So it would be SPTR dot LName, SPTR ID, or SPTR GPA. So there's an example on Canvas that has all of these. It has an array of structs, a pointer to structs, and all of this information, and you have an assignment where you need to go through and change everything, which will hopefully force you to read the code.